Hey guys, welcome back to my shop and my shop adventures with this Jones and Shipman 540 surface grinder. Those who saw my last videos saw that I did some oil repairs on it, and the machine, I got it running again, but it gave me some vibrations, as you can see here on this surface, so I was not happy with that. I checked the system and it turned out that the motor shaft was bent. It had a lot of run out, so that at least that was causing some vibrations. That was not good. So I pulled the motor, I welded the shaft straight. That worked quite alright. So that was my last video. But now it's time to put on the new bearings and then also balance the rotor and the belt pulley, and then see if the runout of the pulley is still good on the motor and on the bearings itself. So yeah, let's do that, and let's get to work. So I got the belt pulley on, and as you can see it still has quite some runout. So I put some cardboard in between here and the steady rest, so I get as little as possible chips in there. That would be good. So let's clean it up, turn it down. So I set the compound slide at an angle to get the radius on the pulley. Started with 4 degrees at both ends, then 3 degrees between these two lines, and then I did 2 degrees with the last run. And you can see the line here in the center, so that's my check that both are the same, left and right, and it's nicely in the middle. So let's do 1 degree and then flatten it out, put some sandpaper over it and call it good. So all nice and clean. Also cleaned the back side because that was wobbling also a little bit of run out, so that helps with the balance. And I even cleaned the inside, so it's all nice and straight. Cleaned the rotor a little bit, and I think that should work fine. So it still has a little bit of run out, like 500, maybe 6, and that is maybe because of the combination with the steady rest and the live center. I did put in a new center, so I think that was quite alright, but still there's always maybe some difference in there, or on this point it will bend a little bit, so you're not quite sure what is happening to the shaft when you turn it down. And it does move a little bit if I remove the center or put it back in. Not too much. So not sure why there's still a little bit of run out, but I will remove the pulley, put the fan back on, mount the bearings, maybe balance the whole shaft, put it in the motor, check the runout again on its own bearings, and if I'm not happy, then I will turn it in the motor itself on its own bearings. And don't tell me this is original. I didn't do it, so I think someone just removed the shaft maybe when replacing the bearings and just dropped it, maybe even a few times. And that's why the shaft was bent. That's probably what happened. Interesting, if you look at these, this one is cut down. I'm not sure if that is a way that they're balancing these shafts. Got the fan back on, it's aluminium, but it also has some bent parts and just a little bit of runout. So I guess I need to bend a few of these back in line. Let's call that good. So let's check the balance of the rotor. I pull the pulley off to see how the rotor and the fan are balanced, but it looks to be quite alright. Got it set up on a V-block parallel and a carbide insert shank. That works quite alright if you level your surface plate. This looks to be good. I tested without a... but don't touch it too much or it will fall off. I checked it without a rotor on there because I want to see if this one is balanced enough. If I put a rotor on there, then maybe these two will compensate for each other, but if it has a very heavy point here at the bottom and a very heavy point at the top for the rotor, it will still give some torque movement on the shaft that I don't want. If you want to balance it properly, then first do the rotor. Now I will put the rotor or the pulley back on, and then I can balance that in combination. But the shank itself looks to be good enough. So got the rotor back on, and as you can see, that one is out of balance. Light point around the blue dot, heavy point down there. So as you can see, there are already some holes drilled for balancing, and interestingly it's all on the blue dot area where it's the lightest, so the heavy point is down there. There's one little hole down there, and so I need to drill a few extra holes in there, but I don't want to take it off the shaft, put it back on, take it back off, and I can't reach it with the drill right now. So I use a Dremel tool to put on put in some tiny holes and check for balancing, and then yeah, see how much I need, and then maybe clean it up with the drill afterwards, just a little bit. But let's start with the Dremel tool. So I ended up drilling 3 little holes. And balance looks to be good. Never perfect in this setup, but it's not a car turbo, and for this motor it's a lot better than it was before. Yep. So 3 holes were enough on the other side of that, so maybe I would just order a new one without the holes and it would be balanced again. Whole lot better than it was before. So let's pull the pulley back off, put on some new bearings, and let's mount it in the motor. Getting ready to put the bearing on. Have it on the electrical heater plate to warm it up a little bit. Right, that's one. Yep, solid. Alright. So, got everything clean. Cleaned this also a little bit on the inside, so it's ready to put back together. Alright, back to the welding table. Not sure that's a good sign. So got the bracket mounted, motor back together, bearings are on there, pulley is on there, checking the runout. Runout is about, let's show you guys. Runout is about 0.1 millimeters, 0.1. So 1/10 of a millimeter. And yes, you could argue that is probably good enough, or it's not causing any vibrations, but yeah, I didn't come this far to leave it like this, and I'm not happy with the runout. I think it was caused because maybe the steady rest was not at the exact correct height and center, and if they're not in line, the shaft was bent a little bit when I turned it. That is maybe one reason why it still has run out. The other thing that I can think of is that I balanced it afterwards, but it was quite out of balance, so maybe it was going up and down while I had it in the lathe. Not sure about that, but with a little bit of movement and difference in tool pressure, because I took very light cuts, maybe the tool pressure was changing a little bit, and that causes the run out. Okay, how to fix it? Well, I can put a lathe tool over here and then maybe run it across, but then I still have the problem with the maybe out of balance and with the tool pressure. So what I will do is I will use my grinding tool with the small grinding stone and use that, because that needs very little tool pressure. Just doing it by hand and see if that works. And I hooked it up at my VFD that I will normally have for the belt grinder, and you can see I can spin it real slow, so that way I don't have too much problem with the out of balance situation. So let's try if I can get it a little better than this. Not sure if this tool will work. It's a little bit experimenting how it works, but it shatters a little bit, so that's not good. I did dress it, but let's try a different one. So the die grinder and the angle grinder were not really working. So I'm testing this tool out. It's a CBN, it's a L-bore, it's a Russian brand CBN, and it has a very sharp point, and I know these take very little tool pressure, so I will try to do a handheld version on there. Now that, guys, is a lot better. So I tried grinders, sanding wheels, angle grinders, but this bench grinder worked the best. And a little bit of sandpaper, and it was fine. I had some problems with all the tools because the motor is mounted on rubbers, so it's moving, as you can see. So even if the tool pressure is really low, then it's still moving quite a lot. I thought about backing it up here, maybe with the bearing to get the movement out, but the problem is imagine that this is a camshaft with a large bulb over here, then that one will, and it's low over here, high over here. When the cam is mounted or coming in this position, it will pushes that direction, and the low point will get even lower and the high point will stay high. So that's not good. And yeah, thought about it for a while, and then I saw this one standing in the corner and I thought, let's give it a try, and that worked brilliantly. Dressed it a little bit and then just moved it around on the cardboard, slide it around, and I could even use the rubber to give it a little bit more pressure, move it up and down, and yeah, that worked the best, and I'm now finally happy with the Runout. So let's put the motor back in the machine. So I got the motor back in. Time to put the pulley back on, hopefully for the last time. Hands up if you would argue that I need to balance it again. Yep, maybe. Yes, I did turn it down after balancing, so maybe it's not perfect anymore. But at some point you have to stop, because hands up who would balance it again? Probably not. And my idea with this is like the grinding wheel. You dress it, then you balance it, and then you dress it again. So I turned it down, balanced it, and turned it down again, and I think this will be good enough. So let's put it on using a little bit of Loctite. Final check on the Runout. It's a little bit hard to do with hand rotation because it's mounted on rubbers, so it's moving with a very tiny force and holding the camera. But I think it's well within 400, I think 3. Yeah, you can see it's moving up and down quite a bit. Put some torque on it. So the old belt was delaminating a bit. So I ordered a new one from England. Do you remember this one, guys? Well, same wheel. with a balanced motor, and that is a whole lot better. It works. So I got the machine running again and the motor repair is finished, so that's a really good thing, and I'm really happy with the surface finish and how it turned out. I still got a lot of work on the machine. In the future I want to mount a DRO, I want to hook up the cooling system, work on my balancing systems, and yeah. But for the future, I already bought them. I was not happy with the sound, maybe they're still good, but I want the best surface finish that I can get out of this machine, and I think the bearings need to be replaced. So yeah, thanks for watching and yeah, joining me on this adventure with the machine. Hope you guys enjoyed it, and I hope to see you next time. Bye bye.